All right, so on page 439 today, we're going to talk about and work with trapezoids and kites. And we're going to start off with a trapezoid. Is a quadrilateral. With one pair of parallel sides. And those are called the bases. The parallel sides of a trapezoid are called the bases. Non-parallel sides are called legs. So if we draw a four-sided shape with two parallel sides, all right, so if we're told that the top is parallel to the bottom, then the top is called a base, and the bottom is a base. The other two sides, non-parallel sides, those are called legs. And you have two sets of base angles, all right? You got a pair on the bottom, and then you've got another pair up on the top. All right, so trapezoid, quadrilateral, parallel sides are called bases, non-parallel sides are called legs, and you have two pairs of base angles. You got the two angles down here at the bottom that go with that base, and then you have the other two angles up top that go with your second base. So now you want to look at the theorems there related to isosceles trapezoids. They're a little more special and they have some special properties associated with them. If a trapezoid is isosceles, then each pair of base angles are congruent. All right, there's one rule related to an isosceles trapezoid. A trapezoid, let's see. The trapezoid is isosceles, then each pair of base angles are congruent. And let's write the word and. Diagonals are congruent. And also, if the legs of a trapezoid are congruent, then it is isosceles. All right, so if we're going to sketch a isosceles trapezoid, it's still four-sided. And it's still got two parallel sides. But now look, if AB is parallel to CD, then we've got a trapezoid. If AC is congruent to BD, now we have an isosceles trapezoid. And there's some other properties that are associated with that. And all of these properties work conversely. If these two sides, if the legs are congruent, then this top pair of base angles are congruent, and the bottom pair of base angles are congruent. See it? And if that's the case, then a segment drawn from C to B is going to be congruent to a segment drawn from A to D. So AD would be congruent to BC. And what you have to understand about these trapezoids is that you can get this information in any order. Here's what I mean. I started off by telling you that the legs were congruent. And if the legs are congruent, then the base angles, each pair of base angles are congruent, and that the diagonals are congruent. Now that same thing holds true. If we had just a trapezoid here, and we drew in the diagonals, and you're told the diagonals are congruent, if the diagonals of a trapezoid are congruent, then the legs are congruent, and the two pairs of base angles are congruent. All right? And the third way you could get the information is that you could be given a trapezoid and told that one pair of base angles are congruent. If we just had this picture up here, and all you were told is that angle C was congruent to angle D, then what the rules allow you to determine is that the legs are also congruent, the top pair of base angles are congruent, and the diagonals are congruent. All right, so if any one of those things is true, then all of those are true regarding isosceles trapezoids. Okay, so keep all of that in mind when you're doing your practice today. If any one piece of it's true, then it's all true. All right, so turn the page. Let's take a look at page 440. Up on top, they've got a picture of a speaker, and I'm going to draw that trapezoid again. FGHJ. The speaker shown is an isosceles trapezoid. If the measure of FJH is 85, so this angle right here is 85 degrees, F to K is 8. F to K is 8. So K is in here where these diagonals intersect. F to K is 8. J to G is 19. All right, so JG equals 19. Find the measure of FGH. We need the measure of angle FGH. All right, so if the first thing we were done is we were told that this trapezoid is isosceles. So the left side is equal to the right side. The top is parallel to the bottom. Okay? Angle J is congruent to angle H. We know all of this because of the previous theorem. Angle G is going to be congruent to angle F. And the diagonals are the same length. We just wrote all of that down. So the first thing you're asked is find a measure of FGH. FGH, that's this angle up here in the top. Well, here's what we know. We know that J is congruent to H, so H is also 85 degrees. And now we have 4 angles in a triangle, right? Or I'm sorry, we got 4 angles in this trapezoid. And if a shape has 4 sides, then the sum of its angles is 360. And angle F and angle G are both the same as each other. So the equation we're going to write is that angle F and angle G, I'm just going to change those to an X because they're the same as each other. So we've got a 2X plus this 85 plus 85 down here on the bottom, right? That's 170. Has to equal 360. So we can subtract 170 from each side. And 2x is equal to 360 minus 170. 190. And then we're going to divide both sides by 2. And our x is equal to 95 degrees. All right, so the measure of angle FGH is 95 degrees. The next thing you're asked to find is KH. So you were told in the beginning that J to G is 19. All right, that's this whole diagonal. If J to G is 19, then isn't F to H 19? Diagonals are congruent in an isosceles trapezoid. And if F to H is 19 and F to K is 8, then wouldn't KH be equal to 19 minus 8? The length of the entire diagonal minus the length of the short piece of the diagonal gives you the length of the other piece of the diagonal. So 19 minus 8 is 11. So there's your K to H. All right, you get the idea? In the isosceles trapezoid, you're just going to use the rules, apply the rule to the information that's given, and then the information that they're asking for. Again, if the trapezoid is isosceles, the legs are congruent, both pairs of base angles are congruent, and the diagonals are congruent. All right, so with that, let's look at page 441. And on page 441, we have what is called the mid-segment of a trapezoid. Mid-segment of a trapezoid connects the midpoints of the legs. The mid-segment of a trapezoid is a segment that connects the midpoints of the legs of a trapezoid. It is parallel to each base and its length is the average of the bases. Mid-segment of a trapezoid connects the midpoints of the legs. It is parallel to each base, and its length is the average of the bases. So let's draw this up. Trapezoid. AB and CD are the bases. So if we go to the middle of each leg and put a point, now if B to F is congruent to FC and AE is congruent to ED, then E and F are the midpoints of the legs. If E and F are the midpoints of the legs and we connect them, EF is a midsegment. All right, it's parallel to each base, so parallel to each base, and its length is the average of the bases. So if you're told that AB is equal to 10 and DC is equal to 18, then EF, the length of EF is equal to 10 plus 18 divided by 2. 10 plus 18 divided by 2. All right, and 10 plus 18 is 28 divided by 2 is 14. All right, so the length of this mid-segment would be 14. The other thing you're going to be asked is to, let's say you're given this trapezoid. Let's put one on its side. All right, we got this triangle here, or trapezoid here, MNOP. We're told that MP is parallel to NO. We're given this other information. That M to Q is congruent to Q to N. P to R is congruent to R to O. So if we have midpoints of the legs of a trapezoid and we connect them, we now have a midsegment. What you'll be given is the length of one of the bases. Let's say the length of NO is equal to 21. The length of QR is equal to 17. And you've got to find MP. All right? So if you have to find the length of MP, remember the formula. All right, the midsegment was equal to the sum, or I'm sorry, the average of the two bases. So if we write that out as an equation, we can say that the midsegment, which is 17, is equal to one of the bases, which is MP, plus the other base, which was 21, divided by 2. Midsegment equals the sum of the bases divided by 2. So we're going to solve for MP here. Multiply both sides by 2. And 2 times 17 is 34. And 34 would equal, look, we multiplied by 2 to get this 2 out of the denominator. So 34 equals MP plus 21. So we subtract 21 from each side. And 34 minus 21, 13 is equal to MP. All right, so our MP is equal to 13. So that's how you can use the formula for the length of, excuse me, the length of the midpoint, midsegment, to find one of the other bases. Okay? So any questions on midsegments or finding the length of a midsegment or a base? All right, then your practice for today. Is going to be on page 444. Eight through 11. And then over on the next page, 16 through 21. Again, your study guide is going to be tomorrow. And make yourself a note to print SEMX1 study guide.